Well, everyone in today's world is talking about data. Everyone is interested in having a good amount of data so that they can analyze and make intuition out of it. But why this data is so important, why we need a huge amount of data set, why this data is so important, we'll understand all these questions in this lecture. So there are three very important terms, that is data, information and knowledge. So what exactly data is? Data can be any unprocessed facts and figures which don't have any interpretation or analysis. So for example, if I am saying the price of orange is $80 per kg. So this statement is very clear. There is no analysis, there is no interpretation, there is no further knowledge with this particular information. So there is no further interpretation or analysis with this data. This is just a raw data we have. Using this data, we can extract some information like this. For example, if I am saying the price of oranges has risen from $70 to $80 per kg, then here we can say that we have some meaning for the user. That means I am saying the prices of oranges is increased to $10, right? From $70, now it's $80. So here we have a little bit of information. And now comes the knowledge. What knowledge we can extract from this information is that when the orange prices go up by $10 per kg, then there will be the role of some market growth, right? So there will be some factors involved in this scenario for increasing the price of oranges. So this is data versus information versus knowledge, right? This is clear-cut difference, that how we can extract information, then how we can make this information useful and can extract further knowledge for our use. So that's why data is so important, and using this data we can extract these things. So as I am showing you this picture over here, we have a data, right? We apply some techniques over this data and we extract the information. After refining this information and using different machine learning models, or you can say mathematical models, stat models, or basic maths, we come up with this knowledge. And using this knowledge, we perform different tasks which were required when we took this data. So that's why all of this is very important. From data, we extract information, and from information, we are extracting the knowledge. And this knowledge is of utmost importance. That's why big companies are investing so much on data. First step is the data source. We collect our data using paper, files, web documents, scientific experiments, or databases, right? Or there are different sources to collect the data. This data is in very raw form. So this is database analysis, okay? Now this data goes to the data warehouses where we process this data, okay? Or you can say we refine this data. From this, the data moves to the exploration part where we apply stats or different database techniques to make our data a bit useful. Then this data goes to the data mining department where we extract the information from our data, and this work is done by data analysts, right? So the data analyst mines the data and extracts the information from this particular data. Now, using this information and the data we have, we get the data to a presentable form so that we can easily understand the data and make some intuitions using this data. So we apply the visualization techniques and combine this data with this information, right? And then this task is done by business analysts where they form some visualization, some meaningful visualization so as to make excellent intuitions out of our data. Then these visualizations along with the information goes to the decision making part where we extract the useful knowledge from our data, right? So this is the cycle how our data moves from a raw data to a pre-processed data, then exploration, then mining, and then the visualization, and finally we extract the knowledge using the data we have, the information we have, and the visualizations we have. So this is the combined team effort to extract the knowledge from the most raw form of a data, right? And now we'll understand different types of data that we have. So number one is the nominal data. You can also say it categorical data. Why? Because in this case, this data set is required to just label the variables. Okay. As you can see that in case of what is your gender, we have two kind of data, that is M for male, F for female. In case what is your hair color, we have brown, black, blonde, gray, and other. And similarly, where do you live? All these data sets, male and female, and all these colors are not in quantitative comparison to each other. We can't say that male is greater than female, or male is equal to female, or brown is equal to black, black is greater than blonde, right? So there is no quantitative comparison between these data sets. These are just the label to differentiate different data. And that's why we can say that this data is basically the categories to understand the data. Okay. Now, the second form of data we have is ordinal data. And the ordinal data is a kind of the ordering data where we can have a quantitative analysis, but there is no fixed interval between the data. So for example, we have a data of how do you feel today. We have very unhappy, unhappy, okay, happy, and very happy. So you can say that this is a kind of neutral scale, and this is towards negative and this is towards positive. But how negative this emotion and how positive this emotion is, you can't describe in numbers. You can't tell that the interval between okay and happy is equal to happy or very happy and very unhappy. So these intervals are not defined, right? There is no well-defined intervals, but there is a ordering, right? So in case of here, we have neutral, this is the border case, and then we have positive and this is negative, right? So moving towards this side, we are moving towards negativity, and moving towards this side, we are moving towards positivity. But how much positive and how much negative, we can't describe. So this is ordinal data. We know that there is some quantity involved, but we can't say how much different these labels are. Then we have interval data, and in this data, it is more or less like an ordinal data, but we have equal intervals in it. So for example, if I'm saying that the temperature difference is 29 to 30 degrees, so there is a difference of 1 degree. And if I'm saying that we have a temperature difference of 78 to 79, then also we can say that we have an interval of 1 degree. So this data, okay, and this data interval is same, both equals to 1 degree of data gap, right? So this is known as interval data. Now we have binary data. Well, this data is in two forms only, 0 and 1. We all know what binary means, right? So it is a special case of nominal, ordinal, and interval data, and it is used in case of classification tasks where we have to describe a data with two labels like yes or no. So we can say 1 or 0. Similarly, if we say male and female, then we can describe male with 1 or female with 0, right? So these are just label. This doesn't mean 1 is greater than 0. This doesn't mean 1 is greater than 0. These are just label. So there is no quantitative comparison. 0 is not less than 1 or 1 is not greater than 0. These are just labels like AB, right? So these are just label which are there to differentiate the data. Then we have count data. Well, in this data, what we have is we count the data set. For example, the number of votes we are getting, so we'll say A vote, and some party is getting B vote. So this will be the count of data, right? So this AB will be the count values in our data set, right? Or suppose if we have a Walmart data set and we are calculating the purchase of different items. So item A suppose has 5,000 purchased items. In case of B, we have 1500 purchased items. So our data will be in the form of figures, and this quantity will be the count. So this is count data, and it is very much useful for making the bar graph. So if I'm saying this is A and this is B, then this will be the purchase of A and this will be the purchase of B. So you can see the clear-cut difference in case of these purchased items. So that's why this data is so useful when we analyze the data. Then we have time data. Time data is a cyclic data which repeats continuously. It can be in the form of days, weeks, months, or years. So for example, it can be in the form of 15 September or only October, or we are talking about years 2019, 2018, right? So this can be the form of data in case of time. So thank you for watching this video. Keep following and best of luck.